Welcome to Real Physics. This is a series of short clips about questionable concepts in physics, and today I'm talking about the Planck length or the Planck scales. Well, at first there's nothing wrong with the idea of thinking about natural constants, and Planck was a smart guy. He observed that if you combine the gravitational constant, Planck's constant, and the speed of light, you can end up with the units meters, seconds and kilograms. So for example, h times g divided by c to the third power, you take the square root and you end up with a length. Turns out that it is 10 to the minus 35 meters, very small. So unfortunately we are very far from any experiment, and we cannot even expect that we will arrive there ever, because I mean, if you think about the reasonable scale which is accessible, it's 10 to the minus 15 meters, the size of an atomic nucleus. It's already difficult compared to the size of the Earth, and you have 20 orders of magnitude. But if you go to 10 to the minus 35 meters, it's still 20 orders of magnitude. Okay, so really absurdly small, and also absurdly small time scales if you divide it by the speed of light, and the mass scale is correspondingly high. So why I don't think that this is a reasonable thing, we will not have any evidence, but it's a misunderstanding that this is something fundamental, because these 20 orders of magnitude are actually related to another riddle in physics, which is a real riddle. I talked about this, Dirac's large numbers, and Dirac's large numbers are 10 to the 40. Okay, so if you for example, the size of the universe divided by the size of the proton, and so if you take the square of this, and you end up with 10 to the 20, and that's how these Planck scales are constructed, because you have the square root, and that's 10 to the 20 out of 10 to the 40. So I think it's nothing wrong to ponder about natural constants, but it's just the wrong way of phrasing it. And so the Planck length, they have made a career in theoretical physics of people who in first place don't understand a lot of fundamental constants of nature. They try to dismiss them and say, no, it's not important, we can always substitute it by the Planck length. No. Physical constants do tell us something, but the Planck length has become a pretext for getting rid of these constants. And the second thing is that it's an ecological niche for non-falsifiable theories. If you go to the 10 to the minus 35 meters, you can develop any fantasy like strings or loops or whatever, and you never get your theory falsified. Okay, this is a problem. So my advice is, if you are interested in fundamental physics and you hear people talking about the Planck length, run. Okay, if you enjoyed the video, don't forget to like it, and as I said, if you're interested in fundamental physics, subscribe to this channel.